we started talking about this concept of relationships. When two or more entities are associated with each other, we would like to capture that information into our model, and so we have an instance of what we call as a relationship. So, we gave an example, it turns out to be a binary relationship, but in general there can be binary or ternary relationships. So, we also talked about what is called a degree of a relationship, which is if it is two participating entities, then we have a binary relationship. Otherwise, if it is 3 ternary, then otherwise if it is greater than 3, then we call it as n-ary relationship. Binary relationships of course are, and we also talked about the diagrammatic notation for representing relationships. We represent the relationship as a diamond box, and then draw all these participating entities around it, and then connect the participating entities to the box by lines. That is how we use this in a diagram. Now, let us move on. I want to, there is a lot more information about these relationships that we would like to capture in general, and so we will focus on binary relationships because they are the ones that occur more frequently than other kind of relationships. So, when we talk about binary relationships, one of the important things that we talk about is what is called a cardinality ratio of this binary relationship. So, let us so it is denoted by having these kind of numbers on these lines that are connecting the entities to the relationship. So, this is binary because there are two entities that are connected with the relationship R, relationship type R. So, I kind of use this relationship type and relationship interchangeably, but we often be talking about relationship types. Okay. So, what is the maximum number of entities from E2 side that are associated with E1 and the vice versa, kind of determines what is the cardinality ratio. We call that as a cardinality ratio of this relationship R. Okay. And usually four different kinds of cardinality ratios are used to kind of model the different possibilities of these associations. So, these are the 4 possibilities are usually specified like this. We call them as 1 to 1, written as 1:1, 1 to many, 1:n, n generally stands for many. So, and many to 1 and many to many. So, we will define these things in the next slide. So, it is 1 to 1 means an entity E1 may be associated with at most one entity. So, remember that we are saying that it is the maximum number of entities that it might be associated with. So, an entity E1 may be associated with at most one entity E2, and similarly an E2 entity may be associated with at most one even entity. If that is the case, we call that kind of relationship as a 1 to 1 relationship type. On the other hand, 1 to many is that an E1 entity may be associated with many E2 entities, whereas the E2 entity may be associated with at most one E1 entity. Okay. And inverse of this, I mean, situation is many to 1. That means an E2 entity may be associated with many E1 entities, whereas an E1 entity may be associated with at most one E2 entities. I will give you examples of these different kinds in the next few slides. Finally, we have many to many cardinality ratio, in which many E1 entities may be associated with a single E2 entity, and a single E1 entity may be in fact associated with many E2 entities. So, we will look at some examples to make these things clear. Before that, I have a picture which kind of gives you clarity about this. So, this is 1 to 1 is here. So, you can see that, remember that is maximum. So, this is some of the entities might not be associated with any entities on the other side, but here because it is 1 to 1, if at all it is associated, it is a maximum of 1. So, it is like that. Here is 1 to many. So, each of these things may be associated with many E2 entities, and so that is the max. So, max is many, they may not be associated with anybody also. Whereas here again this E2 entity is associated with at most one E1 entity, and the reverse is the kind of situation in many to many, many to one relationship. Whereas many to many, many E1 entities may be associated. For example, all these three associated with this, and then these two entities are related with that. So, I will show you examples of this in practical. We will take this the educational institution model that we are talking about, and in that we will discuss various examples. Okay, let us begin with 1 to 1. Again, the whether a particular relationship type satisfies these kind constraints depends on the modeling the situation at hand, situation at ground, right. So, for example, if there is a policy in the institute saying that each professor teaches one course. So, no two professors do not simultaneously teach the course. Okay. So, in such case professor teach course association called the teachers is a 1 to 1 thing. In a similar way, suppose there is a policy in the institute that the students have to be allotted single rooms, so to say, I mean each person has to be associated exactly one room. So, resides in association between students and hostel rooms is a 1 to 1 relationship, right. So, you actually if you say that these are maximums, then then you might actually wonder that is there a course that is can there be a course without any teacher. So, we do not normally expect that in an academic in this kind of a model. If a course is there and it is to be taught by somebody, right. So, we will also have to be bothered about the minimums, right, whether it is associated with at least one professor or not. I mean, we cannot allow a free floating course without nobody committing to teach that course, right. So, we have to bother about the minimums also, we will come to that a little later. Okay. So, that is how some of these relationships will naturally be 1 to 1. Moving on, here are 1 to many and many to many, many to 1 kind of relationships. Let us say we have a policy in the institute that each professor has to belong to exactly one department. Again, this is a ground reality, a policy in the institute. It is the institute might as well adopt a different policy in which it allows professors to be associated with multiple departments as well. Okay. But let us assume that in this situation each professor administratively belongs to one department. Okay. In which case, and also many professors will belong to one department. So, it is a many to one association. Also, you might in this situation it is also natural to assume that there cannot be a freestanding professor without belonging to any department. So, every professor must belong to one department. So, that is a minimum associations that we are. So, in the association we want to also say that the professor has to belong to a department. Here we are now saying that he is at most one department, whereas a department should have at least one professor and can have several professors. Okay. So, like that we then this is a many to one relationship. So, right now we are only bothered modeling the maximums, and we will also see later how exactly to take care of the minimum participation also. Now, let us look at this. Professor guides a student. Okay. Here is a one to many relationship. So, each professor can guide multiple students, and a student is always guided by at most one professor. Let us say that is also a policy. I mean, it is not sacrosanct, but let us say the institute has adopted a policy saying that each student is to be guided by one professor, so that he is not too confused about what to do. Let us say if multiple professors guide the student, maybe there is a lot of confusion as to what to do, right. So, let us say the institute has adopted a policy saying that a student has to be guided by one professor, and in order to cater to many students, the institute obviously says that you should guide many students. Okay. So, each professor should guide many students. So, the association between professor and student captured by these guides is a one to typical example of a one to many relationship. Okay. So, are there any questions? We are so these additional information as to whether an association is a one to one, one to many, many to one, many to many, is in fact telling us some semantic information about the domain, and we would like to capture that and record it in the when we are in this notation or in a similar other alternative notations are there. So, somehow we need to keep track of this information, that because that is when the modelers will understand the domain in a better way. And later of course, we will see how exactly this entire thing will influence the design of the actual design of the relational database system. Now, we also have an example of some examples of this many to many relationships. So, students typically, so if you look at this enrollment relationship between students and courses, it is a very natural many to many relationship. So, a student enrolls for in a semester a typical many number of courses. The student is associated with many courses, okay, and a course has many students enrolled for it. A course has many students enrolled for it. We have 52 students in this class. Like that, many students are enrolled for one course, and a student enrolls for something like 5-6 courses. Right. So, the enrollment relationship between students and courses, if you see, is a natural many to many relationship. Many entities on one side are associated with a single entity on this side, and similarly many entities in this side are associated with a single entity on the other side. Now, I have also given some, okay, one more example here is the works for relationship between a professor and a sponsored project. A sponsored project is a project that is funded by some sponsor with certain amount to kind of carry out certain research work during a particular duration. So, a 3-year project funded by Department of Science and Technology with value of 25 lakhs is given to a professor to kind of investigate some issues. So, like that, a sponsored projects entity can be imagined, and then professors are associated with sponsored projects. Typically, the sponsors might say that at least 2 professors have to be associated with a project, because they can't rely on, I mean they do not want to administratively make exactly one person responsible. What if that particular person develops some health issue and then he has to take leave, I mean who will take care of the project. So at least 2 or more, 3 professors are associated with a sponsored project, and a professor might have multiple research interests and might make multiple proposals to multiple funding agencies and then obtain multiple projects in which he or she is playing a role. So naturally, professor might work for several sponsored projects. So we have a situation which is an example of a many to many relationship here, that professors work for many sponsored projects, and each sponsored project has many professors working for it. Okay. Now, so at this stage of the development of the information system, we will use all these concepts, the concepts of entities and relationships, and capture the domain that we are modeling, and then later when we talk about relational data model, we will see how exactly we will translate this into relational data model. One suggestion that I have for you is that you must, while you are using one data model, just stick to the concepts and the concepts that are tools that are provided in that model. So you should put that cap, so to say. You must put the ER model cap and then think about how to model the situation. Do not keep on thinking as to how we are going to translate this into a relational data model at this stage itself. We will have to talk about it in detail later. Okay. Now, this is one important aspect of relationships, typically the binary relationships. On the other hand, we also have what are called participation constraints. This will talk about the minimums as I was mentioning sometime earlier. So, an entity set may actually participate in a relation either totally or partially. What do we mean by total participation? Is that every entity in the set, that entity set, for example E1, is involved in some association or a tuple of this relationship. That means it appears at least in one tuple. So that is the minimum, right? Whereas a partial participation says that not all entities in this set are involved in the tuples in the relationship. Okay. So the question that we are asking is every entity that is there in this entity set necessarily participate in the association, in the relationship, and so appear in some tuple or other? Is that the case, or it is not the case? So that is the thing. So if it is not the case, we will say it is partial participation. If indeed it is the case that every entity does participate in some association with the entity on the other side, then we call it as a total participation. Okay. And the diagrammatic notation for that is that if it is total participation, then we basically put 2 lines that will connect the entity to the relationship. Okay. Now, let me give you some examples of this. If it is just a single line, then it is a partial participation. We can revisit some of the earlier examples and then see how exactly how. So, for example, if you take this belongs to association between professor and department, we earlier said that there should not be any freestanding professors who are not associated with any department. Okay. So, in our institute we have a policy that every professor must be administratively belong to some department. Okay. This is not a universal policy, but this is a policy of a particular institute. A different institute might allow some professor to be some academic to be just be there in the institute without really belonging to a particular department. It is possible, right. But here we are talking about a situation where every professor must belong to one department. So, this is a total participation. The association between professor and belongs to relationship is that it is total. That means every professor must appear in some tuple here. And earlier we have said that at most one. So, now we are saying at least one, earlier we have said at most one. So, together now it becomes that he has to belong to one department and he has to become exactly one department, he or she. Now, and if you now for example look at the guides relationship, it is not really compulsory for a professor to guide a student. A particular professor might be unpopular and might not actually get any research student to guide. So, we will allow that in the system, whereas unfortunately the students do not have a choice, they have to have a guide. So, we will capture, so if the institute policy is that every student must have a guide whether he likes it or not, we will obviously then the student is having a total participation in the guides relationship. So, you can see that every student has to be in some tuple of other of this guides relationship, whereas a professor might not take might not be guiding any particular any student at all. So, the one here indicates that each student is guided by at most one professor. And he should be guided by at least one professor is what total participation now says. Okay. So, together these two things, the cardinality ratio and the participation constraints, will allow us to capture more detailed information about the relationships that are existing between entities, and we should make use of these tools in order to capture that domain knowledge. So, together they are called the structural constraints. So, cardinality ratio and the participation constraints are together are called the structural constraints. Why do we call constraints is that we could probably call them as structural properties also, but then we will call them as constraints because later on we will see how the information system that we are developing might be actually asked to enforce these things. If there is a policy of this kind saying that a student has to be guided by at least one professor, and then we build the system based on this based on these assumptions, then if there is a student without any guide, then the system will refuse to accept that situation, and then it will prompt you saying that you must supply this information to me, because in your model every student must have at least one guide. Okay. So, that kind of so you could think of them as constraints also, that is why they are called constraints, because the system can be held responsible for enforcing them, so that the information that we have correctly reflects our assumptions about the domain. Here is an alternate notation which nicely captures both these two things together. So, a this is called min max notation. A pair of numbers m and n, where n at least has to be at least 1, is placed on the line connecting the entity to the relationship. And what is the meaning is that m is the minimum number of times a entity must appear in the relationship tuples at any point of time, and n similarly is the max. So, min max, right, this is the min and that is the max. So, minimum number of times a particular entity must appear in a relationship tuples at any point of time. So, if it is 0, then it captures partial participation, right. So, the student that particular entity may not appear in any, so even 0 is allowed. So, that basically takes care of partial participation, and greater than or equal to 1 some number. Okay, you might wonder actually if it is you do not know the actual number, if there is no such okay, we will come to that. So, it should be greater than or equal to 1 for total participation. In a similarly the n is the maximum number of times a particular entity can appear in the relation. So, this is what we have done in cardinality ratio. While talking about cardinality ratio, what is the maxes, right, we talked about that. So, at any point of time it can. So, what the cardinality ratios basically said is that it is many without putting any actual number, but now we have this facility to kind of even make that further precise and then put a number, saying let us say the institute has a let us our department for example has a policy saying that each professor can guide at most 4 students, some number, okay, in order to ensure that there is a good distribution of students across professors. Let us say we adopted a policy that each professor can guide at most 4 PhD students. So, such information we can gather and convey that using this max thing here. So, then you can put the number 4 like for example there to say that this professor can appear in 4 number of these association tuples with 4 different students. So, that way this min max notation as far as binary relationships are concerned will capture this cardinality ratio and participation constraints together, and in fact slightly generalize them to kind of make them even more precise, because we can convey the instead of simply saying many, we can now put some bound on the put a concrete number there. So, it is useful to have such kind of facility. So, so for example, such a many to one relationship will now be equal to this one 1 1. So, it is a minimum of 1 and a maximum of 1. So, for example, you can take faculty member belongs to department. So, he must belong, and it is a total participation. So, he must belong to at least one department and at most one department, and departments might not have professors, can have as many professors as is possible. So, there is no upper limit on the number of professors that they have. So, supposing the institute says that your the maximum number of faculty that you can have as determined by the student faculty ratio is some 40 or something like that, some number, then you can probably put that number there. Okay. So, that way these notations are very useful to capture the domain knowledge that we are modeling, and they are not so difficult to kind of convey to a person who does not know computer science. So when we engage in discussions with the stakeholders for whom we are building the information system, these concepts are not too difficult to kind of explain to them. So we will explain these concepts for them and talk in terms of these things and then gather the information that we are supposed to model. So these are rigorous enough to capture the information, but simple enough to actually explain. Now moving on, it is possible that any questions in whatever we have been talking about? It is possible, just like additional information about entities was modeled using the notion of an attribute. An attribute says entities have attributes like name of the student, roll number of the student, and so on. We talked about attributes of students. In a similar way, these relationship types also can have attributes. Okay. For example, this is a very typical relatable attribute, right. So if a student enrolls for a course, at the end of it he or she will get a grade, letter grade, saying that yes, you got the highest grade yes, or the next highest grade A or B, etc. Your performance in this course is graded like this, so you get a letter grade. So this grade attribute is has values from these symbols that are used to represent the performance shown by the student. And you can also now typically see that this particular attribute is in fact the attribute of this association between the student and the course. It is not an attribute of the student alone, because the student typically takes several courses. Student entity cannot simply have a letter just associated with that, because the student and the course combination is the one that has this letter grade associated with it, right. When the student has taken that course, this is the grade that he or she has obtained. In a similar way, it cannot be an attribute of the course, because what do we be giving a letter grade to a course, right. So when the student has taken a course, then that association is the one that has the grade attribute. So many times it is natural to kind of give this facility of having attributes to the relationship types also, and so we do give that option, and so attributes can be associated with relationship types. Of course, okay, we will show you some maybe some more examples of that. Yeah. Now, for example, professor belongs to department, it is a many to one relationship that we looked at earlier. The join date could be a possible attribute as to when the professor joined that particular department, which is a natural attribute because he is associated with the department. If you observe a little keenly here, since each professor belongs to exactly one department, right. So maybe it is possible to migrate this attribute to the professor, right. It is possible to kind of migrate this to the professor, but we could as well associate it with the relationship. It cannot be migrated to the department, obviously. The join date, whose join date are you talking about, right? The department cannot have a join date, but it kind of naturally belongs to this association between professor and department. It is possible that a professor has served one department for some time and served another department a little later, and so you might want to actually have this join date as associated with the professor department combination. Okay. Now, here is another attribute we talked about professors getting involved in sponsored projects. So, if a professor is involved in sponsored projects, the sponsoring agency might like to know what is the percentage of time that you are going to devote to this project. Okay, you have certain working time, you have teaching and other commitments. Okay. So, but we would like to know how much is is given to this particular sponsored project. So, the percentage time given to a sponsored project is a possible attribute in this context. Recall that this is a many to many relationship, and so the percent time is in fact is a attribute of the association between professor and a particular sponsored project. So, a professor might have 3 sponsored projects and then might say that okay, I am going to give 10% of my time to each of these 3. Okay. So, these are interesting scenarios which we can capture using these conceptual tools that are available in. Any questions in what we have been talking about? Here is another interesting idea called recursive relationships, and associated with that is role names. An entity set might relate to itself and thus kind of gives rise to what is called a recursive relationship. I mean, this is slight in database parlance they use this term, but you can it is not the same sense of recursion as we see it in other contexts. Basically what we have here is that there is a relationship type, and in that relationship type an entity is participating more than once. So far I said there are some participating entities. So, I never said that a particular entity should not participate more than once in a entity in a relationship type, right. I will show you an example of such a kind of a thing right here. The prerequisite of is a relationship, and you can see that the entity course participate 2 times in that, in the sense that one as a course, the other one as the prerequisite course for the course, right. So, so we have to then kind of distinguish as to how in what role it is this particular entity participating in the association, and so we have to have what are called role names associated with the participation of the entity in the relationship. So, that will disambiguate as to what role this particular entities is taking up. Now, so here is a picture. So, prerequisite of is a relationship, and a course is participating in this relationship. So, basically what we are saying here is that certain courses are prerequisites of other courses. That means, unless you complete that course, you should not take the other course. Prerequisite, the meaning of prerequisite is very clear to you. So, unless you do data structures course, you should not take databases course, for example. So, the data structures course is the prerequisite for the database systems course. So, the course entity which is basically consisting of all these courses is participating in this prerequisite of relationship once in the role of a course and once in the role of in the role of a prerequisite. So, these role names become essential to kind of say that how the course is associated with the how the entity in general is participating in the relationship. Okay.